This lecture describes food processing methods and the different degrees of food processing. I thought it was interesting that our textbook started off with 3 different definitions of food processing, the first being very generic, everything that happens to food between farm and fork. And a more technical definition is the application of unit operations to affect desired changes in food. And then finally, the most value-laden definition is changes made to food to make it more profitable, typically at the expense of consumers' health. The first form of food processing is physical. This includes grinding, forming, advanced meat recovery, homogenization, high-pressure processing, and extraction. These methods use pressure and force to yield a desired change in the food. At a macro level, a beef carcass could be divided into smaller portions, or cheese could be shredded, or at a microscopic level, food particles can be broken down into even smaller pieces. Physical methods of food processing can also include changing the shape and texture of the food. A second kind of food processing is thermal, and of course, humans have been applying heat to food since prehistory. The various methods include retorting, blanching, pasteurizing, hot smoking, extrusion, and steam peeling. In addition to making food more palatable and easier to digest, heat can improve the safety of food by getting rid of microorganisms. In fact, the device shown on this page is a retort sterilizer, which steams food after it's been sealed, heating containers to temperatures of 230 degrees Fahrenheit to 275 degrees Fahrenheit. The growth of microorganisms can also be slowed or stopped by the use of a third food processing technique, which is temperature lowering. Specific methods include blast freezing, spray cooling, vacuum tunnel chilling, cryogenic freezing, and freeze drying. The fourth food processing method is food formulation, which is the act of combining ingredients to create a new or improved food. This is accomplished with the use of additives, and let me just describe some of the lesser known ones. Emulsifiers are used to prevent the separation of oil and water in food, and naturally they can include yolks, but they also can use polysorbate 80 and brominated vegetable oil and glycerin esters. Stabilizers help prevent the separation of all ingredients and impart a more substantial structure to the food. This includes gelatin, guar gum, and pectin. And humectants prevent the loss of moisture. Salt and sugar are the oldest forms of this additive. And other commonly used humectants include sorbitol, glycerin, and propylene glycol. It should be noted that not all processed foods are alike. They fall into 3 general categories: minimally processed food ingredients, and highly processed foods. Even though there is no universally accepted method for categorizing processed foods, it is helpful to make the distinction between foods like pastries, which are highly processed, flour, which is a processed food ingredient, and milk, which is generally considered minimally processed. These distinctions allow for a more nuanced discussion of food and food processing. Minimally processed foods include vegetables, fruits, legumes, nuts, meat, and milk. These foods are not substantially changed from their raw, unprocessed form and retain most of their nutritional properties. Minimal forms of process include washing, peeling, slicing, juicing, and removing inedible parts. Some nutritionists also characterize freezing, drying, and fermentation as minimal forms of processing. And to prolong shelf life or inhibit the growth of pathogens, perishable foods may have preservatives added to them, or they may be sealed in sterile packaging. Some minimally processed foods and beverages may be exposed to controlled amounts of heat, or in some cases radiation, to inactivate pathogens. Milk, for example, is commonly heat pasteurized. Processed food ingredients include flours, oils, fats, sugars, sweeteners, starches, and other ingredients. High fructose corn syrup, margarine, and vegetable oils are common examples. Processed food ingredients are rarely eaten alone, and they are typically used in cooking or in the manufacture of highly processed foods. To create these ingredients, starting materials such as grains and oil seeds may be milled, refined, crushed, or exposed to chemicals. And unlike minimally processed foods, these techniques radically change the nature of the original raw materials. Processed food ingredients tend to be nutrient poor, meaning they are high in calories relative to the amount of vitamins, minerals, and other key dietary nutrients. Highly processed foods are made from combinations of unprocessed food, minimally processed food, and processed food ingredients. Many are designed for consumer convenience in mind. They're often portable, can be eaten anywhere while driving or going to work or watching TV, and they require little or no preparation. Highly processed foods include snacks and desserts such as cereal bars, biscuits, chips, cakes and pastries, ice cream, and soft drinks, as well as bread, pasta, breakfast cereals, and infant formula. And highly processed animal products include smoked, canned, salted, and cured meats, and products made from extruded remnants of meat such as nuggets, hot dogs, and some sausages and burgers. And many vegetarian alternatives to meats are also highly processed. Highly processed foods are made using techniques like mixing, baking, frying, curing, smoking, and the addition of vitamins and minerals. I'd like to thank the Center for a Livable Future at Johns Hopkins University for the material that helped to make this lecture possible.